So tomorrow your test will be in like, I want to say 2 parts really, like an overview of 2 parts. So the first part will be your answers need to be in radical form, whereas the second part your answers will be need to be in exponential form. So the first thing is you need to know the difference, right? So when this says radical form, it means whatever your final answer is should have a root in it. Now this first question already has a root, so I just need to simplify that root. If the root is just a regular number like this 448 is, the first thing you're going to do is math 5 it and see if that root reduces. So if I type this in math 5, I get a decimal. If you get a decimal for math 5, then you're going to go to y equals and you're going to do 448 divided by x. And what we're looking for in the 448 divided by x is a perfect 6, okay? So if I'm looking at this sheet, I'm going to go to the 6 column. So really the only possibility would be 64 because everything above 64, like 729, is bigger than the number itself. So it's definitely not going to be that one. So I'm hoping that in my table there's a 64. All right, so let's take a look. Oops. I didn't actually put it in. So 448 divided by x, 448, 224, 64. All right, so I'm going to use the 64 and I'm going to use the number next to it, which is 7. So I'm going to do the 6th root of 64 and the 6th root of 7. There are a few ways to do the next step. You can use this if you want. Go to the 6th column, put your finger on 64 and go all the way over. Or you can math 5 each of these to see which, if any, reduce. So to get out of this second mode, so I'm going to math 5, the 6th root of 64, and I'm going to math 5, the 6th root of 7. This is a decimal, so I'm going to leave this as a 7. This changes, so I'm going to change it. So my final answer here would be 2 6th root of 7. Because tomorrow is a unit test, I highly recommend checking your answers. You can check your answer to this by, in the home screen, doing the original question. And after that, doing your answer. Now, when you're doing your answer, you have to separate your whole number from your root by using the times symbol. Otherwise, it won't come up right? You have to use the multiplication sign there. So it was the 6th root of 7. If you're right, your decimals are going to match. All right, so just a way to check your work. Questions on the first one? All right, the second one is already a root as well, but it's a fraction. So we're going to do inside divided by outside. 33 divided by 5 is a decimal. If it was like a 30 divided by 5 is 6, so it's just x to the 6 perfectly, right? But because 33 divided by 5 is a decimal, we're going to look for multiples of that outside number, which in this case is 5. 5, 10, 15, 20, and you don't have to list these out on your test. Once you get to a number bigger than your existing number, that's when you stop the list. So of all of these numbers, I want to pick a number below that one, but the biggest below that one. So I would use 30 here. So I'm going to split this root up into 30. And then the next one has to be a 3 so that they add together to be 33. Inside divided by outside. Is going to give us a perfect 6. We just can't forget that there's an x on that. And when the inside is less than the outside, you're going to leave that part alone. So you are done with that root. We're just going to write that as a 5th root of x to the 3rd. All right, again, because this is a test, you're going to want to check your work. Because this is a variable, I can't check my work here. I've got to check it here. So I've got the 5th root of x to the 33rd power, and then I had x to the 6th. Now to separate this from my root, I have to use a times. And it was the 5th root of x to the 3rd. If this answer is right, everything's going to match here in the table. And you can see that it does. So even though it's a variable, we still can check our answer in the calculator. Everybody okay so far? All right, so for the next one, I've got this 5 in front. It's called a coefficient. We're going to ignore that for now. What we're going to do is we're going to break this up into different roots. We're going to look at the 8th root of 256, and we're going to look at the 8th root of x to the 56th. This is a regular number, so the first thing I'm going to do is I'm going to math 5 that regular number. So the 8th root of 256. Is a whole number. So I'm going to change this to a 2. And for this, I'm going to do inside divided by outside, which works out to a whole number, right? What's 56 divided by 7? So this is x to the 7th. And then I'm just going to bring this 5 down. And this becomes the multiplication property. The multiplication property says we multiply the numbers in front, we keep the base, we add the exponents. So I'm going to multiply the 5 times the 2, keep the x, and there's no exponents to add, so I'll just keep that as a set. You could totally check this one in your calculator too. For time's sake, I'm not going to do it. But you could, in y1, do 5 times, you need to use the times to separate. 5 times the 8th root of this, and then in y2, put 10x to the 7th. Just like I did that last one, but now you've got numbers involved. You okay with that one? So far we can check everything in the calculator. You just need to know where to check it. All right, so let's look at the next one. Write your answer in radical form, circle your final answer. Now, it's an exponential form now, and if an exponential form has an exponent that's a fraction, which it does, then we can write it as a root. The base stays inside, and then it's inside over outside, so 5 and 3. From here, we're going to do 6 to the power of 5 to make that one number. It's not 6 times 5, it's 6, and then the button below clear. So 7, 7, 7, 6. All right, the first thing I'm going to do is math 5 this and see if in math 5 it reduces perfectly. So it was the 3rd root, which it doesn't. So if it doesn't work out perfectly, we're in our y equals screen, and we're doing this. And we're looking for a perfect third. There's a lot of possibilities here for this one. It could be 8, 27, 64, 125, 216, 343, 512, 729, 1,000. Right, so all of them are, this number's pretty big, so all of them are possibilities here. So let's take a look at what we get when we go to our y equals screen. 7776 divided by x. Anybody find it? Or I'm going to be looking for a while, I assume. Let's see. 243 one? And 343 is. 216 is 1, right? Did you guys pick 216? All right, so I was scrolling for a while, but 216 comes out. 36 is next to it. So I'm going to do the 3rd root of 216 and the 3rd root of 36. Now I could math 5 each of them. I'm not going to do that. I'm going to use this. So 216, and then I'm going over and see that this is a 6. 3rd root of 36. Now checking this is the same. You could do it in the home screen. So 6 to the 5/3. So 6 to the power of 5 divided by 3. Oops. 6 to the power of 5 divided by 3. 6 times the 3rd root of 36. Question, answer. Right? Even though they're in different formats, you can still check them. If they don't have any variables, check them in the home screen. If they do have variables, check them in the y equals screen, but you can still check them. All right, so this is my answer for this one. Now the difference in this next one is there's this 4 in front, and that 4 is not touching the fraction, which means it doesn't go in the root. You can only make something a root if it has a fraction, and that 4 doesn't have one. So I'm going to keep the 4 in the front. This is going to become a 6th root of x to the 43. With variables, we do inside divided by outside, but that's a decimal. So what we're thinking about here is multiples of 6. 6, 12, 18, 24, 30, 36, 42, 48 is too much, right? So that's how I know when to stop. I keep adding 6s until I surpass that number. So I'm going to break this up into 42 and then 1, so I still keep that value of 43. Keep in mind there's a 4 in front. That's just kind of coming along for the ride. Inside divided by outside is 7, but there's an x on that. And when the inside is less than the outside, we leave it alone. I'm not going to write the 1, but you can. If you write the x to the 1 on your test tomorrow, I'm fine with that. I could check this in the calculator. I'm not going to, right, for time's sake. But this is y1, and this is y2. When you do this in y2, you need to put a star between those two things, or it's not going to work, all right? Last one, write your answer in radical form, circle your final answer. So this has got a fraction, and this has got a fraction. So I'm working with two fractions here. The 3rd root of 216 and the 3rd root of x to the 7th. Now this is a regular number, so I'm going to math 5 it and see what happens. I believe this is perfect because we just used it. Yep, so it's 6. Now this is a decimal, so I'm going to have to split this up. And I got to think about multiples. 3. 3, 6, 9 is too much. So I'm going to use 6 and 1. 6 divided by 3 is 2, but I'll keep the x on that. And when the inside is less than the outside, we're done. I could check this in the calculator in y1 and y2. If it has an x, you got to use the y equals screen. If it doesn't have an x, you use the home screen. All of the answers we just went over are in radical form because they end up in roots. Does anybody have questions? Okay. Second part of our review today is going to be on page 36, but now we're going to do exponential form. Exponential form tends to be a little faster. You don't have to do as much. All right, so you're going to do column A. You're going to keep it at your desk, and we'll go over the answers. I'm going to actually say 10 minutes because exponential form is faster, so we'll go 8:14 since this minute I'm talking. All right, sorry, yeah, 8:14. So the first 3 should be in, the first 3 should be in exponential form. The second 3 are both. All right, I'm going to keep it to 12. I didn't realize there was some radical on this page. All right, so the first 3, the directions just say exponential form. The bottom 3 say exponential and radical form, so you're doing both. Okay, so we're going to go over these in 12 minutes, and then I think we should be ready for tomorrow. All right, so 12 minutes is at 16. So write your answer in simplest exponential form. So we want to get rid of the root. Okay, to get rid of the root, anything inside the root needs an exponent. That exponent needs to be a fraction. So inside the root, we've got a 1,024 and an x. Two things inside the root. Each thing needs a fraction. The denominator on each of those fractions is going to be 5. And because neither of those things have a numerator, we would filter in a 1 for both of them. Before I can circle this as my final answer, I just need to check two things. One, does this simplify? So can I type that into the home screen of my calculator and get a whole number? So I'll go 1,024 to the power of 1/5. Remember, some of you might need parentheses around the 1/5. All right? If your calculator looks like this, you're not going to get the right answer. You need to use parentheses with this type of calculator around the 1 divided by 5. Okay, so that does simplify. I'm going to change that to a 4. The other thing I would need to check is, does the fraction itself simplify for the variable? So I would do 1 divided by 5, math, enter, enter, and that doesn't simplify. So I can leave that. But if that was a fraction that did simplify, I'd need to change it. If you want to check your answer, because this has a variable, it needs to be in the y equals screen. y1, y2. All right? See if they match. See if the tables match. All right, write your answer in exponential form. Circle your final answer. So we've got two things inside the root, the 250 and the x to the 12. Each of those things need their own fraction. The denominator on both of those fractions is going to be that outside number. Now this has a numerator, so that one's fine. This one doesn't, so I'd have to add a 1 to that. And so that would be 1/3. So I'm going to check the 250 to the 1/3. In this calculator, I'm going to make sure I use parentheses. The other calculator, it doesn't matter. Because it's a decimal, I'm going to leave it as is. It's going to stay 250 to the 1/3. I don't have to go to the y equals screen or anything like that. I'm going to check this fraction, 12 divided by 3, which you probably already know what that is, but 12 divided by 3, math, enter, enter. You can see that that does reduce, so I'm going to change that to a 4. This would be my final answer, as simplified as possible in exponential form. We okay with that one? All right, write your answer in simplified exponential form. So I'm going to take what's inside with or without the parentheses. It really doesn't matter. The parentheses aren't necessary, all right? Now, that thing inside needs a fraction that has a denominator of 6. So you could also just do this. Whichever you prefer, all right? And now I'm going to type that into the calculator and just check it. So 4 to the power of 5 over 6. It's a decimal, so I'm going to leave it. Another way you could do this is, maybe if you don't want to deal with that part, you could also do this. 4 to the 5th, 1,024. Sorry, 1,024, not. And you can change that to exponential form. So inside gets a fraction, the denominator 6. This would be fine. This would be fine. This would be fine. Any of them are acceptable. They're all the same thing. Okay? Whichever one makes the most sense to you is fine by me. Either way, none of them reduce to anything nicer because it's a decimal when you type it into your calculator. Questions on that? All right, now the last part. This is what we did on Thursday and Friday of last week. We take exponent properties, we simplify the exponent property, then we write as a radical. This first one is a multiplication problem because we've got two sets of parentheses. Normally the 80 would be called a coefficient, but because the 80 has an exponent, it's actually called a base. It's below, think basement, right? You're not doing 80 times 80. all right? You're going to keep the base and add the exponents. So I'm adding the exponents on the 80, and I'm keeping the other base, which is x, and I'm adding the exponents on that, right? Multiplication property says we add exponents. So I need to do 1/3 plus 1/6. The calculator will do that for me. 1/3 plus 1/6. If I get a decimal, which I do, I'm going to have to simplify that decimal. So we've got 1/2. So we've got 80 to the power of 1/2. And then I'm going to do 3/2 plus 9. And if we get a decimal like we do, 21/2. This is called exponential form. 80 to the 1/2 is still a decimal if you type it in. All right, so that's exponential form. Because we can write it in exponential form, and because exponential form has an exponent that's a fraction, we can also do radical form, where each of those fractions gets their own root. 80 to the first, and it's a square root. X to the 21st, and it's a square root. What's 80 to the first power? 80. Anything to the first power stays the same. All right, now we're going to math 5 that. The square root of 80 is a decimal. Now in exponential form, we can leave the decimals. In radical form, we can't leave the decimals. So we go here. Now what I'm looking for is a perfect square. Does anybody see a perfect square on that screen? 16. Next to 16 is the 5. I've got the square root. And you don't, for square roots, you don't need the 2. If you want to write this without the 2, that's okay. Every other root you need that, but for the square roots, you don't. The square root of 16 is 4, and the square root of 5 does not reduce. All right, 21 doesn't go into 2, but there is a multiple of 2 it goes into, and that's 20, which makes this one a 1. 2, 4, 6, 8, 10, 12, you just keep going, you get 20. 20 divided by 2 is 10. We just can't forget the x. And when the inside is less than the outside, we are done. And all I'm going to do here is I'm going to rearrange my final answer by putting those two things together and then these two things together. So my final radical form is 4x to the 10th square root, take or leave the 2, you don't have to write it, 5x. Exponential form, radical form, we're doing both for this one. So maybe I lied to you when I said your test was 2 parts. It's probably 3. I haven't looked in a while. All right, part 1, keep everything in radical. Part 2, keep everything in exponential. Part 3 is doing both to the problem. All right, next one, this is the division property. We are dividing coefficients, keeping bases, subtracting exponents. 40 divided by 8 is 5. Keep the base. 15 minus 1/3. All right, so I'm doing 15 minus 1/3. The calculator will do that for me. If it's a decimal, we make it a fraction. 44/3. Exponential form, 5x to the 44/3. Because exponential form has a fraction and that fraction is an exponent, now we can do radical form. The exponent only belongs to the x, so that 5 is just going to hang out in front. It just kind of carries on the whole time. What multiple of 3 is my highest? Is it 42? Is it 42? 42? X to the 42 and x to the 2. Is that 14? All right, so we get x to the 14th third root of x squared, and again the 5 is just coming down. So here is my radical form for this one. 5x to the 14th third root of x squared. Exponential form and radical form. Last one is the power property. That says we raise the coefficient to whatever power's on the outside, we keep the base, and we multiply the exponents. All right, so 3 to the 5/4. If you have that other calculator, the 5/4 needs to be in parentheses. All right, that's a decimal, so I'm going to leave it as is. And then 3 times 5/4. That's a decimal too. So 15/4. So my exponential form is 3 to the 5/4 x to the 15/4. And because we've got fractions, we can do radicals. This one's going to have 2 radicals. One for the x and one for the number in front. All right, 3 to the 5th power is 243. When I math 5 that, I'm getting a decimal. All right, so I'm going to the y equals screen and doing a 243 divided by x. I'm looking for a perfect 4. 81? Yeah. So 81 and 3. And the 4th root of 81 is 3. So we got 3, 4th root of 3 for that one. 4, 12, 16 is too much. So I'm going to use 12 and 3. So we've got x to the 3rd, 4th root of x to the 3rd. My final answer would be the 3 in front and the x to the 3rd in front. 4th root of the 3 inside and the x to the 3 inside. You need to write the 4. If you don't write that little 4, it's a square root. Okay, so that is part of the answer. The only time you can omit the number on the outside is if it's a square root. That's what your test is going to look like. Does anybody have questions for me? All right, so we've got about 15-ish minutes. I'm just going to give you choice for this 15-ish minutes, all right? So choices are you can work on something from column B. Maybe you got something wrong there and you need additional practice. Option B would be the test review guide. I don't know if you finished that yesterday. I don't even know if you looked at it since I wasn't here, all right? But that's there, page 31 and 32. And if you're done all of that and you really feel good, I think the hardest part is the exponent property part. The very last page of your packet, which I'm not sure what it is, help me out here. Page 37 has got exponent property practice. It's like the 2-part. Okay, so I would say if you really feel confident, go to the last page in your packet. I'll work on getting that key on Canvas. All right, so what is that, page 37? Page 37's got all of it together, like those last 3. Got it? You've got your phones, you can listen to music. I know that's not a lot of time, but since I wasn't here yesterday, I felt like I wanted today to be a little more interactive. I'm gonna put it all online right now. I'm just a little behind because I wasn't here yesterday. All right, here we go. Test tomorrow.